Hello everyone, today we are going to explain something. Previously, we talked about the many devices on our network. So, when do these devices synchronize to a neighbor relationship, and when do they synchronize to an adjacency relationship? Taking our MA, which refers to our broadcast network, in this process, multi-access networks are actually divided into our broadcast network, BMA, and NBMA. In our MA network, if each device, each router, establishes an OSPF connection relationship with every other router. In this context, it will lead to an excessive number of OSPF connections, which will increase the load on our devices. At the same time, the network will be overwhelmed with too many OSPF packets. Once there is any change in the network, the LSA in the network might flood even more, and at this time, it will also waste our bandwidth and consume our resources. For example, let's take a look here. If I want to establish adjacency relationships with these devices, this is R1, this is R2, here is R3, here is R4, and here is R5. What is this equivalent to? For example, everyone rents an apartment, and there are a total of 5 people in the apartment. These 5 people have a good relationship, for instance. This is you, and these are some of your other roommates. Now, during this process, let's say one day you discover that the apartment is about to have a water outage. You send out a notification, but you're worried that B, C, D, and E haven't seen it. At this point, you would tell B, tell C, and you would also inform D and E. Now, even though B has received your message and knows about it, he might feel that C, D, and E are also my good friends, so B would also tell C, tell D, and tell E. After B has notified them, if C receives your message but decides to inform their own neighbors, C would also tell B, tell D, and tell E. D does the same. D would tell C, tell B, and tell E, and our E does the same as well. E would tell D, tell C, and tell B. So here, you will notice that there is redundant information being transmitted across the network. Clearly in this process, one person speaks, and the rest just need to listen. As long as everyone hears it, that's enough. But here, if we keep going back and forth talking, it becomes very troublesome. So here, we can choose one. A leader, or we can call this thing doctor, and we can also choose a second in command. Let's call it BDR. Now you might ask why we need a second in command BDR when we already have a leader. It's to prevent issues. For example, right now, you go out to have fun, but in the network you're missing a leader and there's no one to notify others. How can that work? So, we preemptively choose a second in command, just in case the leader encounters some issues. Then the second in command can step up. Here, we choose this doctor. Point B doctor is called the designated object, and BDR is called the backup designated router. The rest, which are neither doctor nor BDR, are called doctor others. At this point, they are similar to the little ones in our network, just waiting for the big brother and second brother to give instructions. So in this context, we mainly select this DR-BDR to reduce the LSEs flipping to red. Now, in this process, we say it's to optimize the OSPF neighbor information of the MA in the network. So in this context, we have selected several roles, DR-BDR and the other. However, in this context, DR-BDR and the other are all our interfaces. For example, if my interface is the DR in this network, is it possible that I am also connected to another device? And when I am connected to this device, my own interface is the BDR. Yes, this is possible. In each broadcast domain, a DR, designated router, and a BDR, backup designated router, are elected, and those not selected are the others. So, when does this election take place? It occurs after the two-way state, and before the X-start state during this process. If I become the DR and it is the BDR, and one day there is an issue with my interface, then the DR, as we say, will go down. After it goes down, the BDR senses it and will become the DR. After it becomes the DR, if the original DR interface recovers and returns to normal, am I still the DR? Well, no, it becomes the other. It becomes a little d. Because once it becomes the DR, it does not support others competing with it. So, how do we compare this DR? How do we compare this BDR? Here, we first compare the priority of the DR, which ranges from 0 to 255, with the default being the larger, the better. If you have two devices here competing, one with a priority of 100 and the other with 200, I will choose the one with 200, as the larger the better. If the priorities are the same, for example, if neither has been changed, and the default is 1, then we compare the router ID of the devices. This is also the larger the better. Then, we select one DR in each broadcast domain. If your DR priority is set to 0, it means you do not participate in the election. You do not want to be elected. If both devices have a priority of 0, for example, if we have two routers here, and we set the priority of both to 0, their relationship will remain in the two-way state and will not proceed further. So we say in this situation, if in this scenario, am I definitely the better one? Am I the DR? Not necessarily, because there is a 40-second election period here. This means that after the initial phase and before entering the X start state, it will actually wait for 40 seconds to see if anyone else participates in the election with me. If no one participates, then I will automatically become the DR. In this process, we only establish this connection relationship with other devices. The other devices do not establish this connection with each other. It's sufficient for them to become neighbors in the topology. What about them? Any messages are communicated by the second one to others. If the second one encounters an issue, then the BDR will notify others, and the subordinates will always need to wait for their notification. In this context, the BDR will also monitor the status of the DR. If the DR encounters any issues at that time, I will take over the role of the DR. I will replace its role and do the work. This is the relationship between our DR and BDR. In our network, we rely on this DR and BDR to achieve communication. So, how do we send messages to point B, and how do we inform the other? Here, we need to add a group. All of its message transmission methods are basically through the main broadcaster. Only by joining the group can I receive it. Without joining, I cannot receive it. All devices send hello packets through 224.0.0.5. If any device wants to exchange DVD packets or LSA packets, it is done through unicast at this time. So what is 224.0.5 similar to in this context? In this process, it's like when we listen to a radio station, there are often submission channels. If someone wants to submit something now, their submission channel would be 224.0.0.6. In this process, any message he has, for example, if he has updates or wants to delete his own routes, will be sent to 224.0.0.6. Normally, other members will check the submission channel. Do you want it? He won't pay attention, just like when we usually listen to the radio. Do you pay attention to whether someone submitted a story today? You won't pay attention. Only the radio host and co-host will pay attention to this 24.0.0.6 submission group. If he thinks, a submission has been received, he will broadcast from 24.0.025. Then everyone, not just the radio host, but also regular users, will pay attention to this 24.0.0.5. So during this process, you can notice when the other has some LSU messages or updates, it sends them to the DR and our BDR through 24.0.0.6. After the DR receives them, it will send them to the others and the BDR through 24.0.0.5. If the others receive them, where do they reply to? They reply back to 24.0.0.6 through this. If the BDR receives the update, it will inform you through the internal channel 24.0.0.5 that it has received the message. Now, if the DR, let's say, is like a radio host wanting to tell some stories, does it still need to go through 24.0.0.6? No, it doesn't. It can directly send updates through 24.0.0.5. So here we say that it listens to both 24.0.0.5 and 24.0.0.6, while the other refers to listening to 24.0.0.5, which is our DRB point. If anyone wants to learn Huawei certification technology or obtain Huawei certification question banks, please send me a private message, or you can leave more comments below the video for technical exchanges.